So this is our tutorial on using the titration formula to figure out the concentration of a base or an acid when we're using a neutralization reaction. Remember, in a neutralization reaction, we're going to have an acid, so our acid, which is our hydrogen ion donator, plus our base, which will have our hydroxide, and that's going to yield for us salt, which is our ionic compound, and water every single time. So this is our neutralization reaction. So just like we had talked about earlier, this is going to give it a pH of close to 7. It's not going to be exactly 7. So let's look at, here's our formula. Molarity of your acid times volume of your acid times the number of hydrogen ions. So you have to look at the formula for the acid to figure out how many hydrogen ions are present. So like in hydrochloric acid, there's only 1, but in sulfuric acid, there are 2. Okay, equals molarity of your base times the volume of your base times the number of hydroxides. So how many OH minus ions are present in your base? So let's look at problem 1. This is the formula we're going to use. So M acid, B acid, molarity of the acid, volume of the acid, and then your number of H plus ions, molarity of your base, volume of the base, and then the number of hydroxide ions present. So here it says if I take 54 milliliters of 0.1 molar sodium hydroxide, so here's my base. This is all the information I need for my base. We know we have 54 milliliters of it. It's 0.1 molar. And there's only 1 hydroxide present in that formula, so 1. And we're going to neutralize 125 milliliters of hydrochloric acid solution. And I'm trying to figure out what's the concentration of the hydrochloric acid. The same thing we're going to do in the titration lab. If you've done it already, awesome. If you haven't, make sure you do it. Okay, so our number of hydrogen ions present is 1. So now all I do is plug this into my formula. I'm going to be looking for this. This is what I'm looking for. Molarity of the acid. So 0.1 times 54 times 1 equals MA times 125 times 1. So we know this is 125 right here. So I'm looking for this, so I'm going to divide both sides by 125. And I'm going to get your molarity of your acid, or MA, is 0.04 molar. So that's your concentration of your acid. So if I ran this titration and I used 54 milliliters 3 times of my 0.1 molar sodium hydroxide, I would figure out that my 125 milliliters hydrochloric acid has a molarity of 0.04. Okay, let's look at problem number 2. In problem 2, I'm going to go ahead and write all my variables down. Okay, some of you while you're writing this are thinking, well, how do you know which one's the acid, which one's the base? If you can recall, all your formulas for acids, their chemical formula starts with hydrogen and just hydrogen. All of your bases are going to end in OH minus or hydroxide. So that's how you're going to know the difference. Okay, so let's analyze this question right here. It says it takes 50 milliliters of 0.5 molar KOH. Okay, so this is my base. I know it's a base because it contains that hydroxide ion, so this is a base. This is a basic solution. So I'm going to go over here. I'm going to write it down. 50 milliliters, 0.5 molar. And I'm going to look, and now I only have one hydroxide, so I'm going to put a 1 here. Okay. Is completely neutralized. 125 milliliters of sulfuric acid, H2SO4. So it even says acid here, so this is my acid. Notice that we have this 2. So that means instead of like up here with HCl, we were able to put one hydrogen ion. Here, we have 2 hydrogen ions. So whatever this is, it's going to be 2. So here, it's a 2 to 1. Okay. So I'm going to write 125 milliliters here. And this is my unknown. So now I'm going to plug everything in. So Ma times 125 times 2 equals 0.5 times 50 times 1. Okay, so 125 times 2 gives you 250. So Ma times 250 equals 0.5 times 50. I didn't multiply by 1 because it means I'm going to get 1. Whatever I get, go with that. So I'm going to divide both sides by 250. And you should get that your molarity is 0.1. Last one. Says if it takes, switch to another color. Okay, so it says if it takes 125 milliliters of 0.05 molar hydrochloric acid, so there's my acid, to neutralize 345 milliliters of sodium hydroxide solution, so that's my base. What is the mass of NaOH used to make the solution? Well, we're just going to find its molarity. Okay, we're just going to calculate for molarity. I won't make out that mass. Okay, so I'm going to plug in what I know. My molarity of my acid is 0.05. My volume is 25 milliliters. And my number of hydrogen ions is 1. My base, I don't know it. I'm going to calculate for that. But I know that I have 345 milliliters of my base solution. And looking at the formula, since there's only one hydroxide present, I'm going to put a 1. So since I wrote the 1s, I'm not going to put those in the formula. I'm just going to use my molarity and my volumes. So 0.05 times 25 equals molarity of your base times 345. Okay, so I'm going to divide both sides by 345. Then I'm going to get that molarity is the base is 0.004. Now I could find mass. All I need to do is take my molarity and divide it by molar mass, and that should give me mass. But I'm not going to do that right now. Okay, so here's your tutorial. Hopefully it helped.